Hello everyone and welcome to Sally and Bytes. Today, I am here to teach Functions in Python, Part 6, for the class 12 students of Computer Science. In this video, we are going to learn scope of variables. Global scope, local scope, using global keyword and LEGB rule. So let's dive in and get started. We already know what's a variable. Let's recall what's a variable. Sometimes we need computers to remember the information we give it and that it calculates during programs. A variable can be thought of as a box that the computer can use to store a value. The value held in that box can change or vary. In Python, variables are used to store values, such as numbers, strings, or other data types. Through a variable we store the value in the memory of a computer. Variable is a named unit of storage. A program manipulates its value. Every variable has a type, and this type defines the format and behavior of the variable. Let's see about variables, working with numbers. A variable is a name that refers to a value. You can assign a value to a variable using the equal sign operator. Here's an example: x equals 5. In this example, x is the variable name, and 5 is the value that is being assigned to it. Whenever a variable name occurs in an expression, the interpreter replaces it with the value of that particular variable. A variable is an identifier or placeholder that holds a value. In other words, a variable is a reference to a computer memory location where the value is stored. In Python, every element is termed as an object. Hence, a variable is also an object in Python. What does variable scope in Python mean? In Python, the scope of a variable defines where the variable is accessible and can be referenced within your code. The scope determines the visibility and lifetime of a variable. The scope of a name or variable depends on the place in your code where you create that variable. The Python scope concept is generally presented using a rule known as the LEGB rule. The letters in the acronym LEGB stand for local, enclosing, global, and built-in scopes. This summarizes not only the Python scope levels but also the sequence of steps that Python follows when resolving names in a program. Let's see the scope of variables in detail. All variables in a program may not be accessible at all locations in that program. This depends on where you have declared a variable. Scope of variables refers to the part of the program where it is visible. That is, area where you can use it. We can say that scope holds the current set of variables and their values. Here we will study two types of scope of variables: global scope and local scope. Global scope means the names that you define in this scope are available to all your code. Local scope means the names that you define in this scope are only available or visible to the code within the scope. Let's learn how to create variables with local scope in Python. Variables defined inside a function's body have local scope, which means they are accessible only within that particular function. In other words, they are local to that function. The local scope or function scope is a Python scope created at function calls. Every time you call a function, you're also creating a new local scope. The local scopes are names assigned inside a function definition or loop. They cannot be accessed outside the function. Let's see an example. Line 1. This code defines a function called my_function. Line 2. Inside the function, there is a local variable named local_variable which is assigned the value 5. In line 3, the function then prints the value of local_variable, which is 5. In line 5, when you call my_function as my_function, it executes the code inside the function and prints the value of local_variable, which is 5. So the output of my_function is 5. In line 6. However, when you try to print local_variable outside the function using print local_variable, it raises a name error with the message name local_variable is not defined. This error occurs because local_variable is a local variable that is only accessible within the scope of the my_function function. It is not accessible outside of the function. Variables with local scope are limited to the block or function where they are defined. Once the execution flow exits the block or function, the local variables are destroyed, and you can no longer access them. If you want to use the value of local_variable outside the function, you would need to either return the value from the function and store it in a different variable, or define the variable outside the function in a broader scope, such as the global scope. You can only access a local variable by calling the function. Let's see another example. Look at line 1. The code defines a function called learn_to_code. Line 3, inside the function, there is a local variable named coding_tutorial which is assigned the string value Sally in bytes. In line 4, the function then prints a message that includes the value of coding_tutorial using an f string. In line 7, when you call learn_to_code, as learn_to_code, it executes the code inside the function. It assigns the value Sally in bytes to the coding_tutorial variable and then prints the message the best place to learn to Python code is with Sally in bytes. The local variable coding_tutorial is limited in scope to the learn_to_code function, and it cannot be accessed or referenced outside of that function. What happens when we try to access that variable with a local scope from outside the function's body? It raises a name error because it is not visible in the rest of the program. It is only visible within the function where it was defined. Let's see another example. In this code, the function learn_to_code defines a local variable coding_tutorial and prints a message using that variable. However, when you try to print coding_tutorial outside the function, it will result in a name error because the variable coding_tutorial is local to the function and not accessible outside of it. Variables with local scope are only accessible within the block or function where they are defined. Once the execution flow exits the block or function, the local variables are destroyed and cannot be accessed from outside. If you want to use the value of coding_tutorial outside the function, you would need to either return the value from the function and store it in a different variable, or define the variable in a broader scope such as the global scope. Let's learn how to create variables with global scope in Python. When you define a variable outside a function, like at the top of the file, it has a global scope and it is known as a global variable. A global variable is accessed from anywhere in the program. You can use it inside a function's body, as well as access it from outside a function. They are names declared with global keyword in a function. Let's see an example. In this code, in line 1, a global variable named global_variable is defined and assigned the value 10. The global_variable is declared outside any function, making it accessible from anywhere in the code, including inside functions. In line 3, the my_function is defined, which does not explicitly declare the global_variable as a local variable. Therefore, when my_function is called, it can access and reference the global variable. In line 4, inside the my_function the statement print global_variable is executed, which prints the value of the global_variable. Since global_variable is a global variable, it can be accessed and printed from within the function without any issues. In line 6, when you call my_function using my_function, it executes the code inside the function, which includes printing the value of global_variable. As a result, the output of my_function will be 10. You can use a global variable inside a function's body, as well as access it from outside a function. Let's see an example. In this code, in line 2, a global variable named coding_tutorial is defined and assigned the value Sally_n bytes outside any function. Being a global variable, it is accessible from anywhere in the code. In line 4, the function learn_to_code is defined. In line 6, inside the function, the variable coding_tutorial is accessed using its name directly. Since coding_tutorial is a global variable, it can be accessed and referenced within the function without any issues. The function then prints a message that includes the value of coding_tutorial using an F string. In line 9, when you call learn_to_code, using learn_to_code, it executes the code inside the function. It accesses the global variable coding_tutorial and prints the message the best place to learn to code is with Sally_n bytes. In line 12, after that, you access the global variable coding_tutorial from outside the function using print, coding_tutorial. It prints the value of coding_tutorial, which is Sally_n bytes, because the global variable is accessible throughout the code. We can access global variable in the absence of local variable with the same name. Let's see an example. In this code, there are three variables, a, x, and y. In line 1, a is assigned the value 2 outside of any function, so it is a global variable. Global variables are accessible from anywhere in the code, including inside functions. In line 2, the function f of x is defined with a parameter x, which is a local variable. Local variables are specific to the scope of the function and can only be accessed within the function. In line 3, inside the function f of x, there is a statement y equals x plus a. Here, x is the function's parameter, so it refers to the value passed to the function when it is called. Since a is not defined as a local variable within the function, Python looks for its value in the global scope. Therefore, the value of a is accessible inside the function, and y is assigned the result of adding x and a. In line 4, the function returns the value of y, which is a local variable defined within the function. In line 6, outside the function, the variable p is assigned the result of calling f of 5. This will pass the value 5 as an argument to the function, and the function will return the sum of 5 and the global variable, a2, which is 7. In line 7, finally, the value of p is printed, which will output 7 since p holds the returned value of the function. We can use the same names in different scopes, but the priority is given to the local variable. Let's consider an example. Look at line 1. The line a equals 2 initializes the global variable a with the value 2. In line 2 and 3, the function func defines a local variable a with the value 10. This local variable a is distinct from the global a and does not affect it. In line 6, the line prints the value of the global a, which is 2. In line 7, the line func calls the function func, which prints the value of its local a variable, which is 10. The local variable is deleted as soon as the function stops running. So, the lifetime of a local variable gets over early in comparison to a global variable. Local variables are temporary and exist only within the function's execution context. They are created when the function is called and cease to exist when the function returns or completes its execution. On the other hand, global variables have a longer lifetime and exist throughout the entire duration of the program. They are defined outside of any function and can be accessed from any part of the code, including within functions. Now, look at this example, line 1. We initialize the global variable global_var with the value I am a global variable. In line 3, we define a function named my_function. In line 4, 5, and 6, within the my_function function, we create a local variable local_var and assign it the value I am a local variable. We print the value of the local variable local_var. We print the value of the global variable global_var. In line 8, we call the my_function. This will execute the code within the function. The function will print the value of the local variable local_var, which is, I am a local variable. The function will print the value of the global variable global_var, which is, I am a global variable. You can check the output on the console. In line 10, we print the value of the global variable global_var outside the function. This statement is outside the function and refers to the global_var variable. It outputs I am a global variable because it uses the value of the global_var variable. In line 11, the line print local_var is commented out because it will result in an error. This line tries to print the value of the local variable local_var outside the function. However, local variables are not accessible outside the function's scope, so it will raise an error. What happens when there is a global and local variable, and they both have the same name? Let's see an example. Look at line 2. The line city equals Denmark initializes the global variable city with the value Denmark. In line 4 and 6, the function travel_plans defines a local variable city with the value London. This local variable city is distinct from the global city and does not affect it. The line 7, the print statement, within the function travel_plans, prints the value of the local city variable, which is London. In line 10, when the function is called with travel_plans, it executes the print statement within the function, resulting in the output I want to visit London next year. In line 13, after the function call, the print statement outside the function refers to the global variable city, resulting in the output I want to visit Denmark next year. This line uses the global variable city because there is no local variable with the same name within the current scope, outside the function. How to use global keyword in Python. What if you have a global variable but want to change its value inside a function? Now, look at this example. In line 2, the line city equals Denmark initializes the global variable city with the value Denmark. In line 4, 5, inside the travel_plans function, the code tries to access the global variable city in the first print statement. First, this is like when we tried to access the global variable defined outside the function. This works fine on its own, as we saw earlier on. In line 7, however, when the code reaches the line city equals London, it assumes that city is a local variable because of the assignment statement within the function. Since the variable city is assumed to be local, the attempt to print its value earlier leads to an error because the local variable city is referenced before it is assigned a value. The error message unbound local error, local variable city referenced before assignment indicates that the variable city is being treated as a local variable but is referenced before it is assigned a value within the function. By default, Python thinks you want to use a local variable inside a function. So, when we first try to print the value of the variable and then reassign a value to the variable we are trying to access, Python gets confused. The way to change the value of a global variable inside a function is by using the global keyword. Using global keyword in Python. Let's see the modified example. In line 2, there is a global variable named city assigned the value Denmark. In line 5, the code then prints the value of the global variable city using an f-string. The output will be, I want to visit Denmark next year. In line 7, after that, there is a function named travel_plans, defined, and inside this function, in line 8, the global keyword is used to indicate that city is a global variable. Let's see, within the travel_plans function. In line 10, the initial value of the global variable city is printed using an f-string. So the output is, I want to visit Denmark next year. In line 12, a new value of London is assigned to the global variable city from within the function. In line 14, the new value of the global variable city is printed using an F string. The output will be, I want to visit London next year. In line 17, after defining the function, it is called with travel_plans. This executes the code within the function. In line 20, finally, the value of the global variable city is printed again outside the function using an F string. The output will be I want to visit London next year. Value of global variable can be modified using global keyword. Now, look at this example. In line 1, the line a equals 2 initializes the global variable a with the value 2. In line 2 and 3, the function func uses the global keyword to indicate that a is a global variable. In line 4, inside the function, the value of the global variable a is incremented by 5 using the expression a equals a plus 5. In line 5, the updated value of a is then returned by the function. In line 7, when print a is called, it prints the initial value of a, which is 2. In line 8, when print func is called, it calls the func function, which updates the value of a and returns the updated value of 7. This value is printed. In line 9, finally, when print a is called again, it prints the final value of a, which is also 7 after the increment. Note that the global keyword is used within the func function to indicate that a refers to the global variable, allowing us to modify its value within the function. Changing a global name used in a function definition changes the function. Let's see an example. In line 1, a equals 5 initializes the global variable a with the value 5. In line 2 and 3, the function func of x takes an argument x and returns the sum of x and the global variable a. In line 5, when print of func of 7 is called, the func function is invoked with the argument 7. Inside the function, it adds the value of x, which is 7, to the value of the global variable a, which is 5, resulting in 12. This value is printed. In line 6, then, the value of the global variable a is changed to 1. In line 7, when print of func of 7 is called again, the func function is invoked with the argument 7. Inside the function, it adds the value of x, which is 7, to the updated value of the global variable a, which is 1, resulting in 8. This value is printed. Thus, the global variable a is accessed by the func function, and any changes made to the global variable will affect its behavior when the function is called. Unlike other languages, Python function arguments are not modified by default. Let's see an example. In line 1, the line a equals 5 initializes the global variable a with the value 5. In line 2 and 3, the function func of x takes an argument x and returns the sum of x and the global variable a. In line 5, the line x equals 4 assigns the value 4 to the variable x. In line 6, when print of func of x is called, the func function is invoked with the value of x, which is 4, as the argument. Inside the function, it adds the value of x, which is 4, to the value of the global variable a, which is 5, resulting in 9. This value is printed. In line 7, finally, when print of x is called, it prints the value of the variable x, which is still 4. The value of the global variable a does not affect the value of the variable x outside the function. In this case, the global variable a is accessed within the func function, but any changes made to the global variable do not affect the value of the variable x outside the function. Let's see the difference between local and global variable. Scope. Local variables are declared within a specific function or block and are only accessible within that particular function or block. Global variables are defined outside any function or block, making them accessible from anywhere within the entire Python program. Accessibility. Local variables can be accessed and used only within the function or block where they are defined. Global variables can be accessed and utilized from any part of the code, including inside functions. Lifetime. Local variables are created when the function is called and are destroyed once the function completes its execution. Global variables last from the start of the program until the program finishes its execution. Modification inside functions. Local variables can be modified inside the function or block where they are declared. Global variables can be modified inside functions, but you need to explicitly declare them as global using the global keyword. Best practice. It is generally considered good practice to use local variables whenever possible to limit their scope, reduce side effects, and improve code maintainability. Global variables should be used sparingly and only when necessary to avoid code complexity and potential issues with unintended modifications. The Python scope concept is commonly explained using the LEGB rule, which stands for local, enclosing, global, and built-in. This rule defines the order in which Python searches for a variable name during execution. When you reference a variable in your code, Python follows this order to determine which variable with that name to use. In LEGB rule, L stands for local. Local scope refers to the innermost scope, which is the scope of the current function or block of code. If a variable is defined inside the function or block, Python first looks for the variable in this local scope. In LEGB rule, E stands for enclosing. Enclosing scope refers to any enclosing or surrounding functions, moving outward from the current function. If the variable is not found in the local scope, Python checks the enclosing scopes, if any, one by one, in the order they are nested. In LEGB rule, G stands for global. Global scope refers to the module-level scope, which means variables defined at the top level of a module. If the variable is not found in the local or enclosing scopes, Python looks for it in the global scope. In LEGB rule, B stands for built-in. Built-in scope refers to the built-in namespace containing Python's predefined names, for example, print, len, range, etc. If the variable is not found in any of the previous scopes, Python searches for it in the built-in scope. The LEGB rule helps Python determine the correct variable to use, ensuring that names don't conflict and that each variable is taken from the appropriate scope. If Python cannot find the variable in any of the above scopes, it will raise a name error indicating that the variable is not defined. Let's see this example. In line 2, we start in the global scope, where the global underscore variable is defined with the value I am global. In line 4, we then encounter the outer underscore function, call in the global scope. So, we enter the outer underscore function. In line 6, inside the outer underscore function, we define the enclosing underscore variable with the value I am enclosing. This becomes part of the enclosing scope. In line 8, now, we encounter the inner underscore function, call within the outer underscore function. So, we enter the inner underscore function. In line 10, inside the inner underscore function, we define the local underscore variable with the value I am local. This becomes part of the local scope. In line 11, the first print, local underscore variable, statement looks for local underscore variable in the local scope and prints its value, which is I am local. In line 12, the second print, enclosing underscore variable, statement looks for enclosing underscore variable in the enclosing scope since it's not in the local scope. It finds the variable there and prints its value, which is I am enclosing. In line 13, the third print, global underscore variable, statement looks for global underscore variable in the global scope since it's not found in the local or enclosing scopes. It finds the variable there and prints its value, which is I am global. In line 15, 17, after executing the inner underscore function, we return to the outer underscore function. The outer underscore function has no more statements to execute, so it returns to the global scope. We reach the end of the code, and the program finishes its execution. In this example, the LEGB rule determines the scope of each variable. Local underscore variable is in the local scope of inner underscore function. Enclosing underscore variable is in the enclosing scope of inner underscore function, which includes the outer underscore function. Global underscore variable is in the global scope, accessible from all functions and blocks. By following the LEGB rule, Python successfully finds the appropriate variable in each case and prints their respective values. Now, look at this example. You can see the yellow box represents local scope, blue box represents enclosing scope, red box represents global scope, and green box represents built-in scope. Now, look at the yellow box, the inner function. Do you remember the rule of local scope? If a variable is defined inside the function or block, Python first looks for the variable in this local scope. So look at the output, the value 18 is printed. Now, look at this example. In the yellow box, which represents the local scope, line 6, e equals 18, is not given. So do you remember the next rule? Enclosing scope refers to any enclosing or surrounding functions, moving outward from the current function. If the variable is not found in the local scope, Python checks the enclosing scopes, if any, one by one, in the order they are nested. So the blue box containing the outer function, the enclosing scope is evaluated and the output is 12. Now, look at this example. In both the yellow box and blue box, which represents the local scope and the enclosing scope, line 6, e equals 18, and line 4, e equals 12 are not given. So do you remember the next rule? If the variable is not found in the local or enclosing scopes, Python looks for it in the global scope. So the red box containing the global scope is evaluated and the output is 6. Now, look at this example. In the yellow box, blue box, and the red box, which represents the local scope, enclosing scope, and global scope, the variables are not given, line 6, e equals 18, line 4, e equals 12, and line 2, e equals 6 are not given. So do you remember the next rule? If the variable is not found in any of the previous scopes, Python searches for it in the built-in scope. So the green box containing the built-in scope is evaluated and the output is 2.7182818284599045. Now, look at this example. The LEGB rule helps Python determine the correct variable to use, ensuring that names don't conflict and that each variable is taken from the appropriate scope. Here, the first line is also blocked. If Python cannot find the variable in any of the above scopes, it will raise a name error indicating that the variable is not defined. Hope you had a clear understanding of the LEGB rule. Thanks for watching. Watch the upcoming videos. Functions in Python Part 7. Flow of execution of a program, using main function as a function and containing function call and recursion. You can check the link in the description box below.